All right, here we are, a quick video on Chapter 3.4, Arithmetic Series. So I want to just briefly walk through you on a general formula to find an arithmetic series. So here we go. It is S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. All right, so what do all these mean? Let's go through the quick definition of each one. S sub n is the sum of the series. Remember, a series is nothing more than a sequence that is now being either added all together or, in some cases, added and subtracted. Some way we're finding the sum of all of those numbers within that sequence. N is the number of terms. Okay? A sub 1 is the first term in the sequence. A sub n is the last term in the sequence, right here, a sub n. So if we have those components, then we can find the sum. Well, sometimes, we don't have the final or the last term in the sequence. So what we do is we can use an alternate form, which I'll show you. But we need to know what a sub n is. A sub n is also equal to a sub 1 plus n minus 1d. Well, this is our term finder. This is the way we find a value within the sequence, okay? Where d is the common difference. We find d by taking the second term minus the first term. All right, so let's look at this alternate view here. We can have s sub n is equal to n over 2 times the quantity a sub 1. Now, if we substitute in a sub n, right? We got an a sub n here. Now if we substitute all this a sub 1 plus n minus 1 times d in, then we'll actually add the two a sub 1's together and we get 2 times a sub 1 plus n minus 1 times d. We can use that formula as well. Alright, so one thing we might see is some sigma notation to find the sum. And that's basically this, is where we have the sigma notation here, and we want to find the sum from the lower bound to the upper bound. If you need to check a video out on that, I've done one before on that. So here is the way we find the term, and we want to find the sum of the 6 terms. S sub 6 is going to be the sum. Well, a sub 1, we need to find a sub 1 because we're going to plug it into our formula over there, get the first and the last term. A sub 1 will be, we just take the lower bound, we plug it in for the n value. 5 times 1 is 5, minus 2 is 3. So our a sub 1, going back to the original format, the first one, n over 2 times a sub 1. We've found a sub 1. Now we need to find the last term. So if we find the last term right here, we can plug in a sub 6, which is the upper bound. And we'll take 5 times 6, which is 30, minus 2 is 28, and we get n is equal to, and n is equal to 6, so we get a sub 6 is 28, So now we have a sub n, or the last value. If n is equal to 6, well then we can plug all this information into our equation. We get 6 over 2 multiplied by 3 plus 28. And when you take that into consideration, you get s of 6 equals 93. All right, another example. Well, here we're asked to evaluate the series given some information. We have a sub 1, it equals 6. We have d, it equals 4. And then we have n is equal to 10. So we can plug basically all these numbers in. Now we're going to choose the second form because it's a little easier given the information. We don't have access to the last term. We could put it in the formula and work it all out and do all that, but why go all through that trouble when it's already embedded into the sum formula? So 10 divided by 2 times 2 times the first term, which is 6, plus our n, which is 10, minus 1 times the d value, which is 4. So with some simplification, 10 divided by 2 is 5. 2 times 6 is 12, plus 10 minus 1, which would be 9. 9 times 4 is 36. So we get 5 times 48, or the sum of the 10 digits is 240. Okay, last one. We might have a situation here where we are asked to find the nth term of a given series, given this information. The sum is 212. We don't know how many terms there are, but the value is 212 once you add up all the numbers in the series. The first term is 16. Okay, that's good. We got something there to work with. And D is 3. So what we can do is now we have to solve for n. So we set it up. We substitute all the values that we have. 212 equals n over 2 times the quantity of a sub 1, which is 16, plus n minus 1 times 3. That's our common difference. So with some simplification, n over 2, 2 times 16 is 32, plus 3n minus 3. We can simplify again. 32 minus 3 is 29. Now if I multiply both sides of the equation by 2, I want to get rid of this 2. That will cancel out that 2. And now we're left with 2 times 212, which is 424. Then that is equal to n times the quantity, 29 plus 3n. Look what we have here. By the time we distribute, we end up with a quadratic. And what do we do with quadratics? We factor quadratics. So let's factor it. Here we go. First of all, we have to figure out what are the factors of negative 424. Well, if you do a factor tree, which I will impress upon you to pause the video and go through and build a factor tree, you will find the factors are negative 1 times 3 times 2 times 2 times 2. Again, reduce them all. We find combinations of numbers that will then add to our good friend 29. Again, this was A times C up here, if you recall the factor method, the division X method. I like it. It's simple. Now what we can do is, what were the factors? Well, 53 times negative 24 is negative 424. At the same time, it also adds to positive 29. So we bring out 3n plus 53. We set it equal to 0. We will get n is equal to 53 over, negative 53 over 3. Well, that doesn't really make sense for a number, a value, especially when n is supposed to be an integer, because we're looking for a number of terms, not some fraction of terms. But okay, let's keep going and find out. Well, we can reduce this 3. That'll go into 24 and negative 8. And so now we can create another set of factors, which is n minus 8. We set that equal to 0, and we get n is equal to 8. And lo and behold, if you go and plug that back in to your n values, you will find you will get the right 212 value. Okay? Hope you enjoyed that. Thanks a lot. Have a great night. Talk to you soon.